Today we will learn calculation of average value for some basic standard signals. So what is average value? When a circuit is connected across DC supply, it transfers certain amount of charges in a given time period. This circuit, here you can see in figure, this circuit is connected across DC supply VDC. It transfers, let's say, QDC amount of charges in a given time period. If the same circuit here, if the same circuit is connected across AC supply, you have to adjust the DC value in such a way that it will transfer the same amount charges in the same given time period as in the case of DC. Let's say the adjusted value is QAC, which should be equal to QDC. Okay, so the basic conventional formula for finding the average value is f of t average is equal to 1 upon time period 0 to t f of t dt. Okay, this is the formula. Here t is the time period. Here t is the time period. Okay, and the this integration is nothing but area. So the shortcut formula becomes area upon time period. Average value is nothing but, you have to remember this shortcut formula, that is average value is equal to area upon time period. So let's see some examples, then it will be clear to you. Okay, so first waveform is output waveform of half wave rectifier. Okay, so we'll first do in conventional method, then we'll go for shortcut. Okay, so this is V of t is equal to Vm sin omega t. Okay, here time period is 2 pi time period. Okay, so you just have to basic integration, that is V of t average, AVG is average. Okay, V of t is equal to 1 upon time period is 2 pi 0 to up to what your waveform is exist, that is 0 to pi. Okay, 0 to pi Vm sin omega t d omega t. So let's do basic integration, that is Vm upon 2 pi minus cos omega t 0 to pi, which is 2 Vm upon 2 pi is equal to Vm upon pi. This is the average value of this waveform. This is this waveform. So if you observe here, okay, if you observe here, you can see this 2 pi is nothing but time period. Okay, this 2 pi is nothing but time period, and this 2 Vm is nothing but area of this half cycle. Okay, area of this half cycle is 2 Vm. Okay, you can remember this, that is area of half cycle is 2 times of maximum value. You can remember this. Okay, so let's see for next waveform. Let me clear this. As we found out, the area of this half cycle is 2 times of maximum value. Area is 2 Vm. So we can observe, we can see here, there is time period is pi. So average value V of t average becomes area, that is 2 Vm upon pi. This is the average value of this waveform. So let's see the next example. So I average, here time period is t. Okay, Your time period is t. So this this is a triangle, right? So you know triangle, area of triangle, half into base into height, which is area, upon time period is t. So you know Im upon 2 is the average value of this waveform. Okay. Similarly, let's find out for next waveform. Here you can see this is a complete cycle. Okay, this is a complete cycle, but this is symmetrical about x-axis. Okay, in the symmetry, if the waveform is symmetrical about x-axis, then the average value over a complete cycle is 0. In this case, you have to find out the average value by finding the area of half cycle and the average value of half cycle. So here you have to find out the average value for only half cycle. So let's find out area of this. You can section this as this is one triangle, this is one triangle, and this is a rectangle. So you have to find out the area of all this and add them. So let's find out, that is I of t average is equal to, this is the first triangle. Okay, so here area is half into base t upon 4, height Im. Okay, so this is t Im upon 8. Similarly, this is the same triangle, also area will be t Im upon 8, and the area of this rectangle is Im t upon 2. Okay, so let's add them. If you add t I upon 8 plus area t Im upon 2 plus t Im upon 8 divided by, here you have to take half cycle. Okay, so half cycle time period is t. So now let's calculate. If you calculate, this is 8 TIM plus 4 TIM plus TIM. Okay, this is upon T. So this will be equal to 6 TIM upon 8T, which will be equal to 3 Im upon 4. Okay, so this is the average value of this waveform. In this case, you have to remember that if the signal is symmetric like this one or sinusoidal wave complete, in a if the signal is symmetric, then you have to find out the average value for half cycle only. Okay, so let's see the next example. Time period is 4. Let's find out the area. Average is equal to area of this 2 into 2 area of this rectangle. Okay, 2 into 2, and then this rectangle is plus 2 into 4 upon 4. So this is 4 plus 8 upon 4, which is equal to 3. Okay, so average value of this waveform is 3. Similarly, let's see the last for this waveform. Your time period is 2t. So average is equal to half into t into 6 upon 2t, which will be equal to t cancel, 6 upon 4, 3 by 2. So average value of this waveform is 3 by 2. Okay, this is how you have to calculate. You have to remember just average is equal to area upon time period.